Hello, everybody. Today we are going to talk about something extremely important in the field of algorithms, that is analyzing the big O running time. This fundamental concept is crucial in understanding how efficient an algorithm is. But before we delve into the analysis part, let's briefly understand what the big O notation is. The big O notation describes the upper bound of time complexity in the worst case scenario. Essentially, it gives us an insight into how the running time of an algorithm grows as the size of the input grows. Imagine we are looking for one of our friends among thousands of people, and if we check each person one by one, that is similar to a big O running time of n, because we have to check n people where n is the total number of people. And however, if the people is divided into blocks and we know where our friend is, we know the specific block our friend is located at, we can ignore the rest and only search within the block. And that is similar to the big O of 1, or constant time complexity. And now let's consider an example. We'll analyze the simple linear search algorithm. As you probably know, linear search checks each element of the list until it finds the target element or exhausts the list. Now, what's the big O running time of this algorithm? It's not hard to guess. It's big O. It's the big O of n. The worst case scenario is when our target element is at the end of the list or not in the list at all. In this case, we have to check each element, hence the time complexity grows linearly with the size of the input. And let's take it up a notch and consider binary search. In a binary search, we start in the middle. If the target is not at the middle, we can discard half our list depending upon whether the target is smaller or larger than the middle elements. Then we repeat the process within the remaining half. So how many steps are there? If we double the size of the list, we only increase the number of steps by 1. That is because we are halving the list at every step. So eventually the big O running time of binary search should be the big O of log n. Now, you might ask, why do we care about the big O running time analysis? Well, when we are dealing with small inputs, the difference might seem negligible. But when we talk about large inputs, say processing millions of records, the difference between the big O of n and the big O of log n is substantial. A good understanding of time complexity allows us to choose the most efficient algorithm for a given task, saving resources and time. And that's it for today. Remember, the essence of big O is not about calculating the exact running time, but understanding how it grows with respect to the input size. Thank you for watching and happy coding.